Okay, lesson 2.10, complex conjugates and division. So as our do nows, we're just going to quickly warm up. As you can see, radical negative 18 plus radical negative 72 become 3i radical 2 plus 6i radical 2. Combine like radicals, 9i radical 2 is the answer. Number 2, as a quick reminder, I to the first power is just I squared is negative 1, I to the third power is negative I, and I to the fourth power is positive 1. Perform the following operation and write the answer in A plus BI form. This is a complex number form. The first is the real number, the second term is the imaginary number. That's why they call it complex. So we combine like terms, keep, change, change. We change this operation to addition, and then we invert whatever the sign is here. We negate. So we have negative 4 plus negative 4 is negative 8, and negative I plus negative 5i is negative 6i. Finally, over here, we have which expression is equivalent to I to the 55th power. And the shortcut for this is division by 4. When you divide by 4, we end up with 13, remainder 3. So this remainder will be the new power, the equivalent. This is the equivalent expression to I to the 55th. So I to the third power is really just negative I. A student brought a good suggestion. They said, why don't you just look for the multiple that's closest to the power, the multiple of 4. And 52 is the closest multiple to 55 without going over 55. And 55 minus 2 is 3, and you get the same result. So here are some of the notes. Basically, all you're doing when dividing with complex denominators, you need to rationalize by multiplying by the conjugate. Okay, just like we had done before with radical expressions, we need to multiply the numerator and denominator by 3 minus radical 2. If you have an I in the denominator, you must realize that I is really radical negative 1, so we need to rationalize. Number 1 and 2 are very simple. It's simply determine what is your conjugate of the complex expression. Well, the first term remains the same. The second term gets negated. So we have negative 5x plus 4i. The conjugate is negative 5x minus 4i. Over here, the answer is 1/2 minus 3/2 I. Number 3, divide and simplify to the form a plus bi. This expression, 2 plus I over 8 minus 8i. As you can see, we have an I in the denominator, and therefore we must rationalize the denominator by multiplying by the conjugate. The conjugate is 8 plus 8i. We must multiply the numerator and denominator, so we have 2 FOIL problems. Let's FOIL the numerator first. As you can see, 2 times 8 is 16. The outer terms give us 16i. The inner terms multiply to give us 8i. They combine to give us 24i. The last terms, I times 8i is 8i squared. I squared is negative 1, so we get negative 8. Combining any like terms, we end up with the numerator 16 minus 8 plus 24i, and 16 minus 8 is 8. So I'm going to keep the denominator hidden while we work this out. 8 times 8 is 64, negative 8i times positive 8i is negative 64i squared, which is negative 64 negative 1, and a negative times a negative is a positive. The O and the I terms cancel out. You don't even have to bother writing those down. And 64 plus 64, when we combine any of our products, we get 128. And that's how we got this expression here. Put it all together as one fraction, and we notice that we can reduce this fraction by 8. We end up with 1 plus 3i all over 16. And here is number 4, similar problem. We must rationalize the denominator. We multiply by the conjugate, 2 plus 9i. We end up, this is the FOIL part for the numerator. We end up with 8 minus 36 plus 44i. The denominator gives us 85. Putting it all together, we have negative 28 plus 44i all over 85. Sage and scribe number 1. So the multiplicative inverse is really the reciprocal. So I recommend that you put a 1 under it, just like this, and then you reciprocate. So we end up with 1 over 3i. Now, because we have an I in the denominator, we cannot leave it like this. It's not rational, so we must rationalize. Well, some students want to multiply by 3i, which is fine, but I think it's easier to multiply the radical part by itself. So we'll multiply I in the numerator and the denominator, because as you can see, 3i squared and 3i squared will give us 3 times negative 1. So the I goes away in the denominator, and we achieve what we wanted, which is a rationalized denominator, negative I over 3. Number 2, a similar problem. What is the multiplicative inverse of 3 minus I? Well, that's the same as the reciprocal. So once again, we'll put a 1 under it, and we will reciprocate, giving us 1 over 3 minus I. And we realize we cannot leave it this way because it has a radical in the denominator. So we must rationalize the denominator, multiplying by 3 plus I in the numerator and denominator. So we FOIL the denominator, and you simply distribute 1 times 3 plus I in the numerator to give us 3 plus I. Anything times 1 is itself, that's easy. 3 times 3 is 9. 3i minus 3i cancel out. And the last term is negative I squared, which is negative 1, which is positive 1. Putting it all together, your final answer is 3 plus I over 10. Best of luck to you.